Let's take a look at this example. Again, we are going to find the limit of the rational function. Like always, we're supposed to check the denominator. Because the denominator is a little bit longer than before, I'm going to do the calculation at the side. So I have 3 times negative 2 square plus 5 times negative 2 minus 2. Negative 2 to the second power is equal 4. 4 times 3 gives me 12. 5 times negative 2 is equal negative 10 minus 2. 12 minus 10 is 2. 2 minus 2 is equal 0. So if you are going to replace x's in the denominator by negative 2, your denominator is going to be 0. We said we do not want to have 0 in the denominator. So what we're supposed to do? We're supposed to check if we can factorize, in this case, denominator and numerator, and eliminate something which is going to give me the value of the denominator different than 0. So let's do factorization. Limit x is approaching negative 2, and if you are going to factorize the numerator, you are going to have 4x plus 1, and I have x plus 2. In the denominator, you are going to have 3x minus 1, and I have x plus 2. We have common factor for the numerator and denominator, x plus 2. Because I have multiplication, I can cancel them out. And this time I have limit x is approaching negative 2. In the numerator I have 4x plus 1, and in the denominator I have 3x minus 1. You have to look at the denominator one more time. Replace x by negative 2. 3 times negative 2 gives me negative 6 minus 1 is negative 7. My denominator is different than 0. That's why I can simply replace every single x in the numerator by negative 2. So I have 4 times negative 2 plus 1 over 3 times negative 2 minus 1. 4 times negative 2 is equal negative 8 plus 1 is equal negative 7 over 3 times negative 2 is negative 6 minus 1 is negative 7. Negative 7 divided by negative 7 is equal 1. This is the solution to my problem. Let's take a look at this example. Again, we have rational function. We're supposed to find limit, and x is approaching 1. We're supposed to look, like always, at the denominator. X, if you are going to replace by 1, you are going to have 1 minus 1 is 0. We said we do not want to have zeros in the denominator. So what we're supposed to do? We're supposed to look at the numerator and check if we can factorize something. We can say that we have x to the 5th minus 1 to the 5th. But how many of us remember the formula for it? Probably not too many. So what we're supposed to do in this case, we'll try to divide the numerator by the denominator and check maybe this is going to work in our case. And I'm going to have x to the 5th minus 1 divided by x minus 1. X to the 5th divided by x is x to the 4th. X to the 4th times x is x to the 5th. X to the 4th times negative 1 is equal negative x to the 4th. Keep in mind that we're supposed to subtract. X to the 5th minus x to the 5th is 0. And I'm going to have positive x to the 4th because negative times negative gives me positive, and I'm going to have x to the fourth, and I'm going to have minus 1. X to the fourth divided by x to the first, we can say, because there is no exponent, is equal x to the third. X to the third times x is equal x to the fourth. X to the third times negative 1 gives me negative x to the third. Again, I have to perform the subtraction. And I have x to the fourth minus x to the fourth is 0, and negative times negative gives me positive, and I'm going to end up with x to the third minus 1. X to the third divided by x gives me x squared. X squared times x gives me x to the third. X squared times negative 1 gives me negative x squared. Subtract. X to the third minus x to the third is 0. Negative times negative gives me positive. I have x squared minus 1. I copy down always this negative 1. Next, x squared divided by x is x. X times x gives me x squared. X times negative 1 is negative x. Subtract. X squared minus x squared is 0. And negative times negative x gives me x minus 1. X divided by x gives me 1. 1 times x gives me x. 1 times negative 1 gives me negative 1. Subtract. X minus x is equal 0. And I have negative 1 plus 1, because negative times negative is plus, is also 0. So that's why this is remainder 0. So I can say that I have limit with x approaching to 1 of the polynomial x to the fourth plus x to the third plus x squared plus x plus 1. Because this term divided by this one gives me this. And if I have the limit of the polynomial, I simply replace every single x by the value to which x is approaching to. So I have 1 to the fourth plus 1 to the third plus 1 to the second plus 1 plus 1. So I have 1 plus 1 plus 1 plus 1 plus 1 is equal 5. This is the solution to my problem.